All right. What I want to do is, of course, see if you have any questions. Do you have any questions about anything, especially what we are covering this week, or about the project that might be of common interest, anything of that kind?
Yeah, so one question that came up, we had a meeting with my group before classes for the use case diagrams. If we're passing information between like a user and our system, is it normal to just have it all be concise and in one step, or do we kind of break it up over multiple steps?
If it is all entered in one interaction, you can just put that in one sentence, saying enter member name and address, whatever, all that stuff. Yeah, there is no need to put that in separate sentences. No.
All right, thank you.
Yeah. Yeah. Anything else?
Um, yes, Professor. We had a question about the used case number 3, add a product.
Mm-hmm.
It says that relevant attributes input by the user are product name, ID, stock in hand, current price, etc. For the ID, shouldn't that be generated by the system rather than input by the?
No, let's say that like a book ID, the product ID would be put in by the user. The reason is you might want to classify products based on some ID, and it may be more, the system may not know what to put in. So,
Okay. And one more thing, when we're adding a new product, stock in hand will be 0, won't it?
Yeah, it could be, or yeah, since I put it there, just accept whatever the user gives you. Yeah,
Sure.
yeah, that was an oversight, but let's just leave it like that. Yeah.
Mm-hmm.
Yeah.
We could say, for example, that the grocery store may receive a few things as a sample and put that as a stock to begin with.
Thank you for that excuse.
Yes.
Yeah. Yeah.
Okay. Sounds good. Thank you.
Thank you. Yeah. Anything else? Yeah, I'm glad that you started working on the project. That really helps. Yeah, and what I want to spend a little bit of time is on the library class that we uh, have in the design. And the other thing I want to emphasize is that there is another reading that is available under the readings folder that is called I think I don't remember the exact name of the document. It is on implementation. It's just fairly easy to spot. It is about implementation, and I think the word implementation should be there. I think I can tell you the exact name in a second. I think it is implementation.pdf. And it is not a long document. It's about 25 pages. It describes the implementation of the library system. We changed the implementation a little bit. The implementation still conforms to the design, but some of the functionalities are implemented using some new classes that were not there in the design, and the communication between the user interface and the library is much more streamlined. So it is far more precise than it was, far more uniform than it was. So the explanation in the textbook is not completely conforming to what is in the implementation. So you should read this new document. I wrote it in 2 days, and so I'm not entirely sure that it is very polished at this stage. That will take a while for me to accomplish. And so please read that. And I would like to get some feedback on anything that is missing or not understandable, etc., so that I can modify that document. That I would really appreciate that. The other thing I wanted to do, as I said, was talk about the library class that we have in the design. So let's talk about that. Let me share the screen. So yeah, okay, here we go. The library is sitting here, and then we have that's not what I wanted to do. Okay, we have the user interface. Let me just call it UI for short. So the user interface is here as a separate class, then library is here. And then, of course, this is a, what do you call, there is some kind of a boundary here in the sense, this is all business stuff. And here it is mostly displaying stuff to the user, right? This guy is here, he's entering data, or she's entering data and receiving data from the system. And the UI is communicating with the library, inputting commands, getting responses, etc. And the library makes use of a large number of objects. They are sitting here. So the library knows about all these objects. Okay. So this could be a member, this could be a book, this could be a hold, this could be a second member, a second book, a third book, then this could be the catalog, and this could be the list of all members, member list. So we have a large number of objects potentially managed by the library. Of course, the catalog contains the list of all books. The member list stores the list of all members, etc. Now, what does the library do? The library supports all these functionalities that are advertised to the world. And so if a member is to be added, it creates a member object, adds it to the catalog. If you have to issue a book, it checks that the member exists by looking at the member list, and then make sure that the book is in the catalog. It is not checked out, which means examining the book. And then if there is no hold on it, it actually marks the book as checked out, puts a due date, etc., and the member is marked as having borrowed the book. So it manages all this. So if you look at all these operations, the operations are going to the library. Anything that you want to do, it goes to the library. The user interface is not supposed to touch any of these objects directly, right? It always goes through well advertised methods like add member or issue book or return book, etc. So all those functionalities are in the library. User interface goes through this, which depending upon the function, depending upon the method, will pick from different objects and do something with them. So if you think about this, in some sense, the user interface doesn't have to know anything about all these folks sitting here. It doesn't have to know that there is a catalog. It doesn't have to know that there is a member list. It doesn't have to know about all the member classes, member objects, book objects, hold objects, transaction objects, none of that. All it needs to know is all these functions: add member, issue book, return book, get transactions, etc., etc. It doesn't have to know the structure of any of these, how they interact, none of that. So this is that kind of an umbrella through which you access the functionalities. The very fine functionalities of all these different objects are collected into well-defined methods. So the user interface is free from all those details. As far as it is concerned, it is a very simple process. Just supply the parameters to any of these methods. It will give you an answer back. Successful or not, that depends on the situation, but it will give you an answer back. This is a design pattern, this kind of an approach. And this pattern is called, this design pattern is called a facade. A facade is like a facade of a building or whatever. It is the interface that you see. It is the thing that covers lots of complicated stuff. All this complexity, only the library knows. Sorry. The library knows about all this stuff. The user interface is simply knowing all these methods. So the facade, what it does is it keeps track of all the objects that it has and uses them in whatever way it thinks is appropriate to achieve this functionality. So there are well-defined ways of interacting with it. So there are other examples that you are used to in the use of a computer system. Let's look at that. Let's clear this. So there are other examples of facade that we use almost on a daily basis whenever we do some programming or whenever we deal with computers. Otherwise, one is operating systems. If you think about operating systems, they of course manage the hardware, right? There is a hardware here and the operating system is on top of it. And we as users do not go to the hardware directly. You go through the operating system. Even if we write a program, we are going through the operating system almost always. So when you want to open a file or start a new process or go to the World Wide Web or whatever, you are making a request either through a command from your window or by writing a program that would do something for you. You are going through the operating system. So the operating system provides you with certain functions. Typically, they are called system calls. For example, start a new process, terminate a process, open a file, read a file, close a file, etc., etc. There are probably 20 or 30 or even 50 system calls in an operating system, or there could even be more, right? So there are lots and lots of resources here. There is CPU, it may have multiple cores, there could be secondary storage, there could be printers, there could be scanners, and there might be, of course, there is memory, and then there may be lots of other hardware components here. In fact, even the disk, you can think of it as a huge chunk of memory, uh, and the files also could be thought of as resources. So it really doesn't matter to the end user to a great extent how all these resources are managed within the or by the operating system. All we care about is all the big things we can do, right? So that is a facade. As a user, I'm not entirely sure I care about how all those things actually get accomplished. When I start a new process, I don't really care on which core it is going to run, how many cores are free at that point, what is the load on the system. All I am concerned about is running my browser, perhaps. Or when I am writing a program, I say, I want to open this file in my program. So I put some statement there and then say, open the file. I don't really care at that point how that actually gets carried out. How does the operating system connect to the device that contains the file? How does it actually go and read? How does it make the disk drive seek to the correct track? How does it read all those bytes and then process that? Oh, none of that is my problem. So an operating system could be thought of as a facade that manages all these resources and gives you well-defined functionality in terms of system calls. Another example would be a compiler. If you have taken ICS 365, you probably remember that a compiler contains several modules. There is a scanner, there is a parser, then there is intermediate code generator, then there is a code optimizer, and finally there is code generator. So the scanner reads your program, maybe the Java program or whatever, C program, whatever, and makes sure that it is divided into tokens. So if you write public class X, then it takes all these letters, then forms a token out of it, and says, okay, public is one word that I got because it sees a space here. Then it reads CLASS and sees a space, then says, okay, I got class. It doesn't know what to do with it, how to make sense out of it. It simply gives that to the parser. And the parser puts all these things together and then creates what is called a parse tree. So it analyzes the various tokens and puts them together to see what the structure of the program is, whether it is properly written, whether a variable is properly used, all those things. And from that information, we convert that tree to what is called, I mean, what is called intermediate code. It could take many different forms. And so it will contain things that are not quite machine code, they're not even assembly code, something in between. And then we look at that intermediate code and then rearrange things. And surprisingly, code optimization happens at that stage before actual code generation. So it is optimizing the intermediate code. And then after optimizing the intermediate code, the more efficient code is converted into machine code, whether it is a Java virtual machine or a Intel chip, it doesn't matter. That intermediate code is converted to the appropriate machine code. And then that is what gets executed. And there may be other things that happen. You might have to link other libraries with your program, so there might be a linker. But normally you and I don't think about all these things when we write a program. We are more busy with actually getting our program right. So all we think about is compilation. So we think of compilation, and that happens through so many different agents that are part of the compiler. So this is another facade, a compiler. Although not many of you are using this, sometimes we take this compiler and think about two parts. One is actual compiling, and sometimes you also think about linking. Linking meaning take what you compiled and connect it with others. So a compiler might have two parts, a compilation part and a linking part. And nowadays I don't use it, but when I used to work with C programs many years ago, I used to do these separately. Sometimes I would compile and then I will compile and link it with other modules that should be that are necessary for accomplishing my task. So there could be a compilation phase and a linking phase. And when I think about compiling these days, I am thinking about both in one fell swoop. But you could think of two different functionalities for the compiler, for the compiling system or the compiler. That is, one is compilation, the other one is linking. So this is another example of a facade. So I think a facade would be an appropriate way to design the project that you get. We have used one facade, the library. There may be a system where you might have multiple facades. You might have a system with distinct sets of functionalities, but the system needs all that. Then you might have facade 1, facade 2, facade 3. They might share objects, or they may have their own exclusive sets of objects, etc., etc. So this user sometimes may use this facade, may use this facade or that facade. So this is a way of developing an umbrella around a large number of objects so that you can avoid the complexity of having to work with those objects yourself, but is taken care of by these different agents. So your application system might contain 3 facades, and so this is your whole application. Okay, so that is what I wanted to say. So this library is an example of a facade. Any questions? All right. Then let's stop sharing this. Okay, so this week we are doing design. So the class exercise this week will be just based on design. And next week we will be looking at the implementation. I have uploaded the Java code, which you can see under class project implementations. It is called class project 1 version 1. That has a number of classes, a few classes more than what the design calls for, because as I said, I have added those classes to make it a little more robustness into the whole thing, making the code a little safer. Okay, and I also added 2 extra pieces of functionality, things like getting the list of all members, or getting the list of all, or rather displaying the list of all members, displaying the list of all books, just to illustrate how you can do that safely, right? So that is something we will look at next week. I am going to remove almost all of the videos that I posted for lecture 8. I'm going to construct new videos tomorrow. I hope I get the time, and then I will post them. So I suggest that you don't spend time on those videos that are already existing for lecture 8. I will try to post new videos based on the new implementation. I have to check, because some of those videos might still be the same, right? Because I haven't changed many of the classes, like hold, for example. I don't think I changed anything substantially, but some classes have been polished a little bit. So I will look at what is current and what is not current, and then keep only what is current, and then create new videos tomorrow. Okay. So read that document on D2L, the new document, as well as look out for new videos. Don't watch those old videos yet. I will also post a new PowerPoint presentation for next week. Okay. Any questions before we start the class exercise? And anybody? Okay, and I will say this again next week. If I remember, there is no class week after next, because week after next is spring break. Okay, all right. Let me then stop recording.